Welcome to a demonstration for the Kamino Code Generator. For this proof of concept, we will be using a very simple application that could be ported between two different microcontrollers, just changing the lower level configurations. So this application will be a very simple state machine where we initialize our hardware, then wait for a Uart message that we receive. In this case, we will wait for the letter 0. We'll transition to another state where we measure an ADC that is connected to a potentiometer. And after that, according to the value of the voltage in the pin, we will either turn on or off an LED. So very, very simple. For this, we will be using the next configuration. On the Atmega 4809 microcontroller, we'll be using pins 5 of the port B as our LED output. We'll be using the TX and RX Uart pins, and one analog pin in the port D, pin 0, as well as the ADC and Uart for communication. So, in order to configure this, we'll be using our code generator. We'll just need to open our project that we already configured for this microcontroller. And now we can start configuring the hardware. So first we'll do the Gpios. For this case, we know we need to configure all of these pins. So we'll go to port B, and select the pin number 5. We know this is an output because it's connected to an LED. We'll select the push-pull configuration, initial value as low. Speed, it doesn't matter in this case, we'll just use fast. And for our code name, we'll use LED. Now we'll go to the port C and select pins 0 and 1. We'll be using the alternate function for these two as Uart. So none of this configuration is available for us. And we'll use these code names as TX and RX. Finally, we go to port D. We select pin 0, the alternate function, and we know it's analog. And finally, set the name to pod. So now we've configured all the Gpios. Next up, we'll go to ADC configuration. We'll use the ADC 1, which is the only one available in this microcontroller. We'll change the name to the pod ADC. We won't be using any samples. Clock source and bit justification are not supported to be configured on this microcontroller. Prescaler, we know we will be using by 4, resolution of 10 bits, and for our voltage reference, we'll use the ADC supply voltage. And we'll be using the channel 0 for this ADC. We'll just name it pod as well. Finally, we go to Uart configuration. For this, we'll be using Uart 1. We'll select it and we'll just leave the Uart 1 name. We can see that either clock source or prescaler, they are not supported in this microcontroller. And for baud rate, this initial invalid value is, well, we know that is invalid because of this label. We'll set it to 9600, and it's now okay. Data bits will use the standard configuration of 8 data bits, 1 stop bit, and no parity. Once we have all that configuration, we just click Generate Code, which is generated successfully, and we can see our newly generated code here in our text editor. So for the Gpio configuration, we have the LED, our TX and RX, and finally our pod pins. as well as their definitions here with the alternate functions, output, or any other configuration selected. We see the same on the UART, which is just UART1. Here's our selected baud rate as well as our configuration. And finally see the ADC, which is the pod ADC with its configuration as well. Now, if we want to do the same for the RT1062, which is an NXP microcontroller, we'll just go open that project. And we'll repeat the same. First, we'll go for Gpios, which this microcontroller has a lot more pins in it. And in this case, we'll go to port 1 and select pin 9, which is a Gpio ADB009. Which is here. It's a lot of pins. So again, you will just set it as output, push-pull, low, fast, and set it as LED. We'll then need, again, all of these pins are in port 1, so pin 12, which is ADB012, this one, and ADB013. These both will be using the alternate function and as UART. So now the generator tells us that these pins are already configured as ADC, and if we want to change that configuration to UART, we select yes. So that should be done automatically. And we can set the TX and RX. Finally, the pin 26, which should be ADB110. It's this one. We'll select the alternate function as analog this time. Just set it as pod. We can go to the ADC configuration, use ADC1. Name it as pod ADC. Again, no samples. For the clock configuration, we'll use the other clock for ADC. Bit justification is not supported to be configured. The prescaler will be by 4, resolution of 10 bits, and voltage reference is not able to be configured here. We now will be using channel 15, which will use the pod ADC channel name. And as you can see, this is the same pin that was selected in the Gpio screen. We go for Uart configuration, in this case Uart1. We select it, just name it Uart1. Clock source and prescaler are not supposed to be configured here. Baud rate will leave it at 9600. Data bits 8. One stop bit and no parity. Now we just generate code and it's generated successfully. If we want to, we can just see the code that is being generated. So we go to the framework folder, down to drivers. We'll check for the ADC, and in the configuration we see the pod ADC and our selected configuration. Then we can go to Gpios, and again we see our pod, LED, TX and RX pins. with our selected configurations, including the alternate functions and output modes. Finally, UARTs. We just have the UART1 with our 9600 baud rate, as well as the standard 8.1 none configuration. And now we can open this code already integrated into our project inside our IDE. In the case for the Atmega 4809, we'll be using Atmel Studio as our IDE in order to not only program this code into the board, but also to debug and check that we are going through the framework in order to control the peripherals. So we go over the initialization, hardware initialization phase, and then into our Gpio initialization defaults. These are the static part of the framework where we have generic functions with the connection to the application. We go through the different peripherals and just initialize our default values that we have selected through the code generator. And now we can see the code actually running on our board. So we have it connected through UART to the computer, and we can check the messages on Docklight. This tells us that the UART module is working. We can read the voltage as we can see it on the multimeter, and that message is being correctly carried through the UART to the computer. So all of these peripherals are working correctly.